谢谢老师上来的。试试看可不可以。
你有下载新的吗？
有啊，下载。
因为我今天没带手机，你连上传都没办法。
哦。是这个吗？
对对对。
我说用这个吗？
对。你开了吗？
开了。有，都开了。
开了。
就开起来。不好意思。上次没开到。这样就可以。你确认一下。还有多少？
哦，在哪？
是这。
哦。Okay. Last time we stopped here. No, we stopped here. Okay, we talking about redundancy, and we discussed inversion and republic blocks. Okay, and so on. Today we will go to another topic. Okay, it's talking about the organization itself. Okay, and before that let's see. Okay, the network services currently most of the network application or service provided we can roughly classify them into two types. One is connection oriented. That means it's like a circuit switch. Okay, before you send out message, you transfer real data, you make connection. Okay, this kind of or this type of behavior we call it connection oriented. Okay? And another one is connection based. That means two entities they communicate. They just communicate. It's like mail or email. Okay, you did not get the permission from the other parties before you send out the real data. You just send it. Okay, and that's connection is type of communication. Okay, so the service of this type of connection oriented usually they are reliable message stream. That means the reason we set up a connection before send out data, that means you expect the communication is more reliable. Okay, so or reliable by stream. Okay, or even sometimes it's unreliable connections. Okay, and this usually is for voice or video streaming. Okay, so the example for this is you maybe, for example, a sequence of book chapters. Okay, or remote login, that's or telnet or whatever. This kind of communication service usually you require reliable by stream. Okay, and for unreliable connection usually is for here the unreliable is just relative to this reliable by stream and messaging. Okay, that means some kind of or some part of the information is dropped or discarded or lost. It is can be tolerated. Okay, for example, when we communicate by using voice or videos, okay, for example, for the voice, usually in general, the sampling rate is about 8,000 okay, hertz. Okay, and so the sampling, that means what? Means you discard some of them. Okay, every second you sample then in 8,000. So you instead of using a continuous, because voice or this information, reality, it's continuous wave form. Okay, however, to transmit, that you will not use continuous wave form to translate. You separate them to translate them to become a digitized data. Okay, so in the sense that, in some sense that you already discuss some of the information. Okay. So for this kind of application, voice or video, okay, some of the data missed is tolerable because our ear is not so highly required. The resolution is not so high. So you can drop out some high frequency information or whatever. Okay, but for the video, it's similar. Okay, in general, no more resolution video. We only require about 30 frames per second. Okay, and during the transmission, in the 30 frame, you lost one or two of the frame. Your eye, most of the people we cannot distinguish. Okay, so for this kind of connection, although they are using connection oriented, but this kind of connection, they allow some kind of unreliability in there relative to this byte string or message string. Okay, for example, this sequence of book chapters. Okay, you cannot allow any information in those, because when that happens, you need to have a way to recover or retransmit. Otherwise, you did not get the whole picture. Okay, and for the remote login type of applications, of course you cannot miss any of the information. Okay, so the reliability degree is a little bit different. Okay, for connection, this application usually is reliable, unreliable data graph. It's like mail, a post mail. Okay. The post office, they deliver this information by mail-based effort. Okay, so sometimes some opportunity the mail may get lost. Okay, that's allowed. Okay, and if you require a more reliable connection in this communication, then maybe you use acknowledgement datagram. Okay, it's like a registered post mail. Okay, so the mail post office, they guarantee they will deliver, although it's connectionless. Okay, but they you pay more, so they give you not just best effort. Okay, they will try to guarantee they deliver. Okay, and a more reliable way is requested, right? Okay, that means you not only just get acknowledgement, say the mail is delivered, but you also get a response back from the receiver. Okay, so it's a double registered post mail, something like that. Okay, so and the application for this, usually, for example, this text package, network testing, you try to pin using the protocol pin or whatever. You just try to see it's possible you can reach some of the network host or whatever, and this is like a registered mail. And the request reply usually is more some typical example is query of the database request, something like that. Okay, so have this network service, and this type depends on their reliability requirement and communication type. Okay, it's connection oriented or connectionless. Then we can discuss the operating system in distributed system. Okay, so the type of operating systems for distributed system, usually we can classify them into three categories. Okay, one is the distributed operating system. The second one is network operating system, and last one is middleware. Okay, the difference is something like that. The DOS usually means you have a tightly coupled system operating system that support not only the multiprocessors but homogeneous multi-computers as well. Okay, and usually they require every host they are running the same set of operating systems. Okay, and they are tightly coupled. Okay, so and the major goal is that they hide all the hardware resources and try to provide a single image view to the users. Okay, so that's the ideal case. You would like something like this. Okay, but it's difficult to achieve that. Okay, so you have two approach. One is loose of this constraint a little bit. Okay, one is you lose all. Okay, then we use a network operating system. That means the operating system they are loosely coupled. Okay, for heterogeneous multi-computers, and they are connected maybe by LAN or WAN. Okay, so every host may have their own operating system. Okay, and hardware may be different. Okay, but they just use some agreed or standard network service. Okay, provided by this individual host. Okay, so collectively they look like a system. Okay, but the usage from the point of view of users, they cannot form a single image view. Okay, so users need to know, need to locate the resource in the system by itself before can use those resources. They need to have a way to locate the resource. Okay, and then ask for the service. So usually in the network operating system, for this kind of system, the resource, specific resource which is in remote, usually is in the form of the service. Okay, they provide a service, so the other the users can use the remote services, and through these services they can use some specific resource. Okay, something like that. Okay. So usually every host they provide some specific services to remote client. Okay, and that's the client responsibility to locate the service first before they can issue the request and to acquire the service. The last one is a compromise between DOS and OS. Okay, so instead of we create an operating system that every node run in the same version. Okay, look like a single image. So you just on top of operating system we provide a layer, okay, an application layer, a specific layer which can transfer this request to underlying service. So it's more like underlying. You may use network operating system, and every host provides some services. But to make those services much easier to use, instead of us, the client, put all the responsibility in the client. So we create a middleware layer. Okay, so those service provider they follow some kind of standard interface or standard practice, standard way to let client be able to locate those services. And instead of every client need to locate a specific service, the middleware provide this locating capability. Okay, so you ask the middleware, instead of locate the service first, you just send your request through this middleware. The middleware itself will locate a proper service, okay, according to your request. Okay, and then the proper service will provide the response, provide the service, and then the middleware will get back the response. Okay, so from this point of view, the user, it's not like DOS is totally coupled, totally managed as a whole, but instead of we use underline is maybe look like network services, and every host provides some specific server, okay, whatever, or service, but they also they all use some standard way to provide these services. Okay, so there's a standard way to locate these services. Okay, and this standard way, standard protocol usually is in the form of the middleware. So the client through this middleware to find the proper services, and also the service after a service receive a request, it does not need to know where the request came from, which particular specific client, but whenever they get a request, you just perform the request, okay, and then generate response. Again, this response goes through this middleware and can come back to the original client. Okay, so from this point of view, the client and server, they are somehow, it's not tightly coupled. They can be loosely coupled. They don't need to know each other, okay, before they can communicate. It goes through this middleware. Okay, so the middleware, the granularity of the middleware can be very cover everything, all kind of aspect, or all resources, or the middleware can maybe only cover some of the resource. Depends on the implementation. Depends on what kind of middleware you choose. Okay, so the degree or the granularity of the middleware can be adjustable. Okay, depends on the what kind of build you try to provide. Okay, what kind of transparency you try to provide to the users. Okay, the most common way for the middleware is file system. Okay, they provide a file access, look like a single image view. Okay, instead of a network file system. So most of the distributed file system is use some kind of middleware to access files. Okay, so whenever you try to access a remote file, you go through this DFS, distributed file system, and you don't need to know the actual location for a particular files. This DFS, they will try to provide this for you. Okay, so that's the major difference to the network file system and the distributed file system. Okay, so depends on the support for the resource. Okay, some middleware they only support file, so that's the file system. Some they may support messaging, so it will be a distributed messaging service, and so on. Okay, so middleware they usually they only provide some kind of transparency, some degree of transparency, depends on what you like to support. Okay, so it's more a realistic way to implement, to support this distributed system. Okay, so for a network operation with something like this, okay, every host would have its own kernel, but they all have some kind of services. Okay, and application they need to find out these services before you can use. Okay, typical services like this. Okay, telnet or FTP or whatever. Okay, it's a standard protocol layer. Okay, so as long as you follow this standard protocol and you know the specific resource you try to use is in which particular host, then you can use this resource sharing protocol or services to ask this service provider to provide these services. Okay, so usually the operating system, the kernel can be different. Okay, and as long as the service provider and this service usually they have a standard protocol to support that. Okay, the typical, the simplest way is the file system. Okay, the network file system is a typical example. Okay, and this kind of network operating system support file sharing. Okay, for example, this NFS. Okay, in the past, originally, and it was generated or proposed by Sun Micro, okay, but now later Sun Micro was acquired by Oracle, so now it's become Oracle interface, okay, or they changed it to another name, okay, it's the same, okay. And this network function usually is something like you have a host contain a big file, a big storage. So the file then provide file service capabilities. Okay. So the other computers, they may have enough storage, so they can store their file into this file server. Okay. This is a typical scenario, something like that. And then whenever you try to access a file, you send a request to this file server, and then the file server make an access, and then send back to this result, and so on. Okay. So this file server, the disk or the storage management by this file server, they are shared by all the client computers. Okay. And the sharing usually by some of the typical way is that the client, before you can access a remote file through this network file system, you need to find out the server, various server, and then make a connection or make a node or register or something like that, okay? Or tell your local host that where is the remote server, okay? And the typical way is this standard protocol is mount, okay? You use this mount system call or mount protocol, then make the remote file server, your file system look like your local file system. Okay, so you put the remote file architecture in your local file architecture, okay, as a part of a tree, okay, or subtree in your file hierarchy. Okay, but in this mount protocol supported by the file servers, okay, but they did not require every computer or every client computer they need to mount these file entries or file directory, file architecture into the same place. Every client can mount according to its own own requirement. Okay, so for example here you can see if we have a two server, okay, and this service one, the server one, they has a directory games and then contain these three files. The server 2 has this directory contain these three files. Okay, and you may have two client computers. Okay, and client 1 they may mount these two directory into its root directory as a subdirectory of its root. Okay, but client 2 it may mount these two directory from the two different servers into not the root directory but / private. Okay, so after this mount, these two computers they can access these files in these two different file servers. However, the access is different. Okay, because of the file name. You execute a program in client 1, you will use the file name /game for this, or /work for this, right? But if you run the same application in client 2, then the file name will be different. Okay, so that's the different. That's the meaning that the different client may mount in different subtree, different place of its file architecture. So for network operating system, through this network service type of the sharing or file sharing, okay, or file service capabilities, they did not provide a single image view. Okay, a different computer they can mount those remote files into different way. Okay, so you need to know whenever you run an application in different kind of host. Then before you run application, you need to know those files actually their file name may be different. Okay, because this mounting usually done by not by the user process, but by the root account or administration. Okay, they do it for their user accounts or whatever. Okay, so a normal user usually they don't have the right to do the mounting themselves. Okay, so you when you log into a particular host, before you try to access some remote files, then you need to know those files for your is mounted in different hosts. Okay. However, to make easy for users, most of the administrator, when they manage these file servers, they will try to mount these remote files into the same hierarchy for different client hosts, especially if those are managed by the same administrator. Okay, for example, in our system, our computer lab in the department, okay, the TAs they will not try to mount this server into different place for different hosts, because if they do that, then it's difficult for the user to use, right? So most of the time, this mounting they will mount into the same place. Okay. And in general practice, okay, for example, to make the user to use this terminal or use client computer much easy, usually they will create all the user directory into these remote servers. Okay, and they mount this remote server because most of the time when you create an user account, then you assign a directory for this user, right, under some particular hierarchy. Okay. But a good convention is something like that. You maybe generate a subdirectory. So for example, /users. Okay, so all the user account, their home directory will be in /users/name1. Okay, that means the user 1. Okay, on user 2, user 3, every user will have its own subdirectory under the /users. Okay, something like that. Okay, and if these /users they are all created in some server instead of in particular client host, and then every client computer they can mount these /users in a particular file server into the same place. Say for example /users, okay, in each client computer. Okay. Then whenever you log into any client computer, if you, for example, if you are in our computer rooms, any Linux server or Linux host, you log into there, your home directory will be the same, okay, because they are mounted into the same place. Okay, that's a common practice. If you get a good management team to manage with this, then usually you will do that. Okay, but however, if these two computer clients they are not managed by the same administration team, they are in different domains, then they may have a different practice, okay, or different convention for that. Okay, so that depends on how they make this. Okay, that depends on the administration. Okay, not depends on the users. Okay, so that's the capability of network operating systems. Okay. And for the distributed operating system, usually they can only use message passing, okay, for the communication. Okay. And some, of course, some systems they may have support distributed shared memory, okay, but usually because it's not a multi-computer, so those computer nodes they may physically they are far away. So usually it's the performance for distributed shared memory in general is unacceptable. Okay, so most of the time the only thing is message passing. Okay, so for this kind of system, usually we have a distributed operating system on top kernels, and this distributed operating system, every host running the same version. Okay, so the application they can run in any host, but they will look the same. Okay, so the single image view is provided by this layer, okay, by this DOS layer. And the last one is, okay, instead this DOS and OS we can treat is a two side okay, of a line. Okay, there are two extremes. Okay, one provide total transparency, one provide no transparency. Okay, the middleware is sitting in the middle. So it depends on how many transparency you provide. You like to provide, then you implement those required capability. Okay. So middle provide transparent and some kind of autonomy, because now every host would have its own operating system. But on top of the operating system, they use a middleware service to provide this transparent capability. Okay. So application, so they need this there to achieve some form of some kind of transparent. Okay. And the middleware model, in general, we can have these four typical categories. One is document-based middleware. Okay, so that means they support document. Okay, in the document layer, for all the document, for example, the typical example is the World Wide Web. Okay, you can treat a system is a collection of documents. Okay, and they use the web protocol HTTPS or HTTP to navigate, to access those resources or those documents. Okay, so everything in this environment is a document, and of course this document have its own typical presentation. Okay, so and another one is file system based middleware. Okay, treat the distributor as a big file system. Okay, and you typically in the past we have this Plan 9, okay, or Inferno. Inferno is a special case of Plan 9, and most of recently is distributed file systems. Okay, they all only support file. Okay, use file system as a middleware. Okay, so everything in these systems is treated. Every resource is a file. Okay. The next one is object-based middleware. Okay, they treat everything as an object. Okay. A typical example is COBA or DCOM, supported proposed by Microsoft, or Java plus IMI. Okay, and these are some. They are in object-oriented way. Okay, so everything is an object. And that one is a coordination-based middleware. That means in general, Linda is a more general way. Okay, and publisher subscriber is more restricted middleware. Okay, if they only consider communication, then the pub sub is a coordinated messaging passing middleware. Linda is a more general. It's not only for the communication. Okay, they can use this for synchronous access to the shared data as well. Okay, so we will discuss this one at a time. Okay, I think everybody knows. So in this world or in this kind of system, it's a network of hyperlinked documents. Okay, so inside a document, you may contain address of the other documents, so you can go through this to visit other documents, to find out other documents, and so on. Okay. So when you try to retrieve a document from web, okay. So for example, we try to get the president of the NYCU, okay, find out information about. Then you may use this URL, okay, and to retrieve your browser usually asks DNS for the address of this server, okay, and the DNS may reply its IP address, and then the browser may make a connection to this particular host, and if it is a standard service, then it will be in the port 80s. Okay. And then after connection, successful, they will send out request to ask for this particular document. Okay? And eventually this server will send back the document. Okay? And then your browser will render this document and display in your console, okay? And so on. And after that, the connection will be maybe released. Okay? So that's a typical way to get a document from Wide Web. An address or the resource or document in this web, usually they have this standard standard mechanism. We call it uniform resource locator. Okay? And this contains 4 parts. Okay? The first part is protocol. Second part is the host name, host domain name, and then followed by phone number, transport layer phone number. That's one is the directory or resource or path name of this particular document, and so on. Okay, so the protocol, you may have HTTP, HTTPS, or other standard protocol or supported protocol. And domain name is something like this with this semicolon, and then followed by phone number, okay, and so on. Okay. For file-based middleware, okay, Print9 is the typical one. Okay, they were first designed in 1980s by many original creator of Unix. Okay, and they are so Print9 is also created by in Berlin. Okay, in that time Berlin and IBM is the 2 most well-known computer labs. Okay, they have most of the good outcome came from these 2 places. Okay, and Inferno is a light and embedded version of Print9. So the goal of Print9 is try to build a Unix out of smaller one. Okay, because in that time the Unix become too big from their point of view. Okay, so they try to build a smaller Unix. Okay, so only reserve the good part of the Unix and toss off the rest of not so good the features. Okay, so they only reserve these 3 structured file system. So everything is fine. Okay, so everything is fine. Okay, so use Print9 for all the resource, file, process, network, device, and so on. Okay. And the resource access protocol, they call it NIP, used to access this. So every resource in this system, they are represented as a file hierarchy. Okay, so they have system resources, services, application. They are all everything has a path name associated with it. Okay? And the namespace may be private or per process by default, can be accessed or changed by users, and they can bind or unite directly together. So they use a standard. So for the both remote and local service resources, the protocol is the same. So using this to achieve access transparency. Okay. Because everything is a file, so you can treat 9P is a virtual file system. Okay, on top of Print9. Okay, the underlying operating system. So local operating system will translate into a file code. Remote will translate to a proxy operation. Okay, and they use request and reply and response, this RPC model to communicate among these hosts. Okay, and because to avoid coherence problem, there's no cache at all. Okay, for all the resource. Okay? Whenever you try to access you access this version. Okay, so every copy has only one copy in any file. Okay, and some of the version of Linux, for example, after 2.6 and 0.14, they will also support 9P also. Okay, under this global definition. Okay, so if you try to use 9P in Linux, it's possible. Okay, if your Linux is in a version after this. Okay. And let's suppose these are basic operation. They have session management, header, file, and metadata management, and so on. Okay. And service is something like this. Okay, file server is just a service of the files, and others are also servers. Okay. For example, you have networking, mail, graphic, Windows system, and process control. Okay, they all has its own path name to support. Okay. And again, because everything is file, so you try to use the remote resource, then you need to mount it into your local directory. It's similar like NFS. Okay, so directory can be mounted together. Okay, and for example, here, okay, you can bind this to bin and also bind this one to bin. That means these are well united into this slash bin. Okay. So here is an example. So you try to copy a local file to a remote floppy disk. The first thing is you would import, okay, this remote floppy disk, okay, to your file architecture, and then you make this copy. So the file will be copied into this remote floppy. Okay, so something like this. Okay. And pipeline is also existed. So you run this food in host 1, and the output will become the input of this bar. Okay. And bar is running. This application is running in host 2, and then you can use this way to specify that. Okay. So later, this idea, okay, because pregnant they treat everything as file, okay, so it's too restricted, okay. Later, distributed file systems was proposed, so they only handle the real file as a file, okay. They only provide file access transparent. The transparency is only for files. Okay, not for the other resources. Okay, so that's the distributed file systems. The first more or less file system is network file system in some micro. Okay, although it's not a distributed, but in some sense because it's the first file system, it can access more files. Okay, not by the download, upload, but by the access. Okay, so we also see it as a part of the distributed file system. Okay, and then later you have Android file system. Okay, and now after that, in 2000, early 2000s, okay, we have this real distributed file systems. Okay, and this for just 4 examples. Okay, if you're interested, you can look. We may later we will discuss this. Okay. And NFS and Hadoop, okay, in our later lectures. Okay, but the detail, if you are interested, you can find from this reference. Okay. In distributed file system, usually they propose 2 kind of access mode or access mechanism to the remote files. Okay. First one is we call it upload download model. And second one is remote access model. Okay. The difference is something like for upload download model means whenever you try to access file, they will copy the file into your local disk, and then you access the local version. After the local version is finished, then after you close, you finish the access, then the local version will send back. If local version has been updated, then they need to write back to the server. Okay, so the server will create a new version for this. Okay, and the original version will be erased or not depends on the implementation of the file system. Okay, some file system they just maintain versions. Okay, so the original version may be still there. So that's up to the user or client which version you try to access. They were still there. Okay, and the remote access model is something like this. It's you just send a request to ask for particular file, and the access was done by the file server. Okay, so file server has a process capability in there. Okay, the access for the client, and then response depends on it. So in here, because sometimes you access a file, you may not need the whole file. You may just access part of the file. Okay, so that's the reason this model was proposed. Okay, and the concurrence management are all handled by the server, because every request came to the same server, right? So if you have multiple concurrent access from different clients, their consistency can be handled by this server. Okay. So in DFS, okay, the directory hierarchy, okay, may be single hierarchy. So for example, all the clients, they see the same hierarchy. Okay, that's one possibility. Okay, and second one is you can multiple directory. Every client may using different hierarchy for the same set of servers. Okay, that depends on the implementation. Okay, so these are typical NFS example, and this more like most of the DFS and Android file system, they support something like this. Okay. The naming in distributed file system, naming means you try to locate a file, right? How to locate, so how to name a file, so the uniqueness of file can be preserved. Okay. In general, you have three common approaches. Okay. First one is you use the machine name plus path name, for example, something like this. It's similar to the URL. Okay. And this can satisfy, this way it satisfies location transferring, because here the host name can be a domain name. A domain name usually did not contain the IP address. Okay, it's different, right? Same domain name can map to different IP address. You can move this domain name around. Okay, you can associate a domain name to different hosts. Okay, that's when that's necessary. Okay. So this name did not tell where this server 1 is located. Okay. So server 1, this domain name can be moved to anywhere freely. However, it's not the file. If a file is associated in a domain name, then you cannot move out of that domain. Okay. So that's the restriction or the constraint of this mechanism. Okay, so a file cannot be moved among these servers freely. Okay, because then you need to change the file name. Okay? Because you change the association of the domain. Okay. The second way is you provide a single namespace for all the hosts, so the files can be moved freely. Okay. So you don't a file has a single unique name in this system. Okay, so and it not only achieve location transparent but also achieve location independent. Okay, because the file can be moving around. Okay, easy. Okay, of course, to provide this is much difficult than provide this. Okay. And that one is like NFS. Okay, so you mount the remote file system to your local file architecture. And each client host may have its own way to do that. So file may have different name when you access the files through different client hosts. Okay. So in general, you have these three approach. Okay. File sharing. Okay, sure. Because by using TFS usually means this file need to be shared by different users. Okay. Otherwise, it's make no sense to make this file become available to others, right? Only this file is some other people or some other application may also need to access. Otherwise, you just create a private file for yourself. Okay. So the reason to share a file is that the file may be needed by other applications. Okay. So then now it it's possible. They may have a concurrent access to the same file through different applications simultaneously. Okay. So we need to consider the consistency. And consistent semantic means that what kind of semantic may be provided by the server. Okay. So in general, it can be defined as a contract between this storage and the client. Okay. So whenever you use this particular distributed file system and they support some kind of consistent semantic, then the client need to know what semantic is provided. Okay. So for the file system or distributed file system, in general we have these four kind of file access semantics, okay, or file sharing semantics. The first one is sequential consistency. Okay. And the idea is proposed by this Lempo, okay, in 79. Okay. Here we call its original words. Okay. So the result of any execution is the same as if this operation, like access file operation, okay, of all the process were executed in some sequential order. Okay, so the name stands for that. Okay, although this access may be concurrent, right, but the result is the same as some particular sequential orders. Okay, of each individual process here in this sequence. Okay. Okay. Then we call it sequential consistency. Okay. The second consistency is this one is very strict, a very strong form of consistency. Okay. The causal consistency means that those has causal relationships or causal dependence operations, their execution may need to be follow this causal dependence. Okay, that's the causal consistency means. So rights that are potentially causally related must be seen by all the process in the same order. Okay, that means if you read something after a particular right, so okay, that means if a read access obtain a value of a particular right access after, okay, then after this read access, no other process can see the others. They must see after this particular read. Okay, so for example, a process read a particular data item and get the value B, for example. Then after this process retrieve the data and return the value is B, for example. Okay. Then after that, all the process, if they access the same item, they need to see B or after B. So after B's update, so the update after B. Okay. Otherwise, then the system becomes causally independent. Okay. The barrier is causal dependence. Causal dependence means if you have this effect, something is affected, okay, and this after effect is already visible, then you cannot go back. You cannot possible to see other things. You need to see things after this. Okay, So that's the causal consistency means. Okay. And FIFO consistency means they only apply for the same process. Okay. So write down by the same process, a single process, need to be seen by all other process in the order of this they were issued. Okay, so the update came from the same process. So for example, a process update a particular item, and originally they update first one, they put the A in there, and the second write put the B in there. Okay, so the order is this particular process write A and then write B. So all the other process, when they see, retrieve or read this particular data item, they need to read A first, and then they may read B. Okay. So after they read B, they cannot. It's impossible to read the particular item and get the A. Okay. That's the meaning. Okay. But this relationship A and B must be generated by the same process. Okay. If two updates to the same data item came from different process, then their order become irrelevant to the other processes. Okay. So that's the meaning of FIFO. Okay. Only those updates came from the same process need to be preserved by the other process. So it's less constraint than the causal dependency. Causal dependency is for all the causal relationship. Okay, this as long as this relationship is existed among those processes, okay, then you need to be followed. Okay, but here only the update came from the same process. Their order need to be followed. Okay, the last one we call it session consistency. Okay, and this idea is first proposed in Android file system. Okay, the reason we call it session consistency, that means it's because every support, they only support this kind of semantic upload download. So whenever you try to access a file, you first should open, and then you get the whole copy of the version, the file. Okay. And then you access. During this access, you may do some update, and this update will not be right back to the server. Okay. Those update will go back to the server only after you close the file. Okay. So when you try to access, you open, and after all the access, you close. Okay. So during the close and this open, and from the open start and to the close, we call it a session. Okay, a file access session. Okay, that's the meaning of the session semantic means. Okay, so after close, this new version will be right back to the server. Okay. So during when a process open for write, the other process may also try to open for write, right? Or open for read. Okay. But because this write has not come back yet, so all the other open, they will get the original version as well. So when the new version comes back, if this one closed, right, then those process they still use this old version, will be informed in the AFS. They will be informed. Okay, and that depends on the application deciding. Okay, I will abort those access and try to use this new version, or depends on the application's requirement. Maybe the old version is still useful. Okay, they don't need to be consistent. So they did not require this strong consistency. Okay, then so that depends on application. Okay, so the idea behind this is that application need to take some responsibility to decide it. Okay, if after they were informed, there's a new version comes in. Okay, so application has the the base knowledge to decide, okay, that the old version is still useful or they need to use the new version. Okay, so that's up the application, up to the application. Okay. So that's the session consistency. Okay. So let update only visible after close. But when you try to open the file, you always get last closed version. Okay. So now that means that the file system, the support for the file system is something like this. Okay. So application need to know whenever you open a file. In the same time, they may have some other application. They are updating the file, but you don't have knowledge about that. Okay. Here we will see some example of this. Okay. A sequential consistency, for example, you have 4 hosts. Okay, and this write XA, that means you put A in X. Okay, and then process 2 write X by B. Okay, and we have these 2 processes. They both. Okay, this request. Here we only show the operation issued by the process. Okay, we don't know when this operation is really be executed by the server. We don't know. Okay, so here we show that the timeline is the requesting timeline, not the execution timeline. Okay, so when the process read X, it may get B first, and then later get A. Okay, so from point of view of process P3, the B was first executed in the server, right? And then A was updated by the server. Okay, that's from the point of view of P3. However, if there's a P4 process, it retrieve X and twice and get this in a different order. Okay, that means this file server, they did not satisfy sequential consistency because the execution order, okay, the execution order of this A and B, they can only be A followed by B or B followed by A, right? Any execution order is good enough. However, everybody must see the same thing. Okay, the result need to same as one particular execution order. But here the result, okay, is 2 different, right? From two point of view of 2 process. Okay, so we don't know. So this is not sequential consistency. However, this satisfy. Okay. If these 2 are all follow the same order, okay, they all see B and then followed by A, then this becomes sequential consistency. Okay. So that's the meaning of sequential consistency. The order must be some particular sequential access, and everybody must see the same order. Okay. The causal consistency means those operations, their causal dependence must be preserved. Okay. So for example, here we have these 2 writes. If these 2 writes are all generated by the same process, then this 2 write has causal dependence. Okay, because this one is first issued by the P1, and then later issued the same by different value. Okay. However, this read they don't have any causal dependence, but in any way, but this write B is causal dependent this write A, because this write B only happen after this process read X and return A, right? And then it do access update X by B. Okay, but this update B and update C, although from the timeline this one may be issued first, but we don't know the execution order in the servo. Okay, there's no guarantee which one will be. Okay, and also these two access, these two update, it's not codel dependent because there's no particular order that need to be followed. Okay, there's no causal relationship between these two operations. Okay, so if after that this P3 do X by C and then do X by B, it's possible, right? Because real execution maybe this one execute first and then this execute extra. However, for P4, it may see this order, right? But from the causal consistency, from the sequential consistency, it's not satisfied, right? Because sequential consistency, the order need to be, everybody needs to see the same order. But from the causal consistency point of view, because this B and C, these two update, there's no dependency. So they can be seen in any order. So although these two processes, they see their order different, but it's good enough. Okay. So that's causal consistency. Okay. That means if those operations they have causal relationship, then their order need to be followed. Okay. But if they are not, they are concurrent. Okay, then any order is good enough. Okay, from the outside world. Okay, because P4 is outside world, right? So this is not sequential consistent, but it is causal consistent. Because now this lines, this arrow lines means the dependence relationship. So if we follow it, then now you can see that these two is there's no relationship between these two. So that's why the order of these two can be different. Okay, from different users' point of view. Okay. But they all follow this causal relationship. Okay. And here's another example. Okay, for example, if this something like this. Okay, and this one is not causal dependency also. Okay, because here this A and B update, the read A must before write B, right? So if you read X and get a B, it's impossible later you will get A. Okay, because A should be followed before B. Okay. So that's why this one is not causal consistency. Okay. This one is good, but this P3 is impossible to get this result if the system support causal consistency. Okay. But if without this read, okay, because if there's this read, then we have this dependency, right? If without this read, then this become causal consistency. Okay, because now these two right, there's no dependency, so any order is possible. And if these two processes see different order, it's also possible. Okay. Of course, it is not sequential consistency. Okay. And for FIFO consistency, okay, only those writes came from the same process. Then you need to be worried about its order. Okay. So these two writes came from the same process. Okay. But here is also causal. This is causal relationship. So from the causal consistency point of view, it is not followed because from this line we need to read A, read B, and then read C. Okay, so this one is good, but this one is not. Okay, from the causal consistency point of view. Okay, but from the FIFO's point of view, FIFO means only those writes generated from the same order, same process. So here, only B and C, the order of B and C need to be preserved because this write is not in the same process. So B, C need to be followed in the same order. That's why this B must be before C, and here B is before C, so it's good enough. Okay? So that's why this one is FIFO consistency, but it's not cordial consistency. Okay? So the reference is from there. Okay? Object-based middleware. Okay? We will discuss COBA. Okay? Conceptually. The COBA stands for this Common Object Request Broker Architecture, a standard defined by this committee, okay, Object Management Group, and this standard was released in '91. Okay. And basically, this standard contains three parts. One is interface definition language. Okay, use this one to define the interface of an object. Okay. And this request broker is a middleware, okay, and this middleware will deliver the messages for the objects. And this inter-op protocol is used to communicate to op, because object request is a middleware, okay, and middleware close the network, then they can the communication between ops is by using this protocol. So in general, COBA have these three parts. Okay? And the official side of this COBA is in here. If you OMG define a lot of object-related standards, okay? So you can find here. The goal of COBA is they try to define an infrastructure which can much easily have this play and plug or plug and play mechanism, so the object can you can easily plug in new services, okay, in this way. Okay. So by using this, it's possible we can develop portable and object-based interoperable distributed applications. Okay. And because it's a standard in middleware layer, so it's independent to the hardware and operating system, and network, and also programming language. Okay, so any programming can be binded to this environment. Okay. So client and server can interact or communicate through this org. Okay. The idea of is a language independent mechanism, a descriptive language used to describe, define an object. Okay. So only define the interface. You don't need to associate with implementation. Okay. And to use the reason for this is that when you after you define an object interface, then you can use this ideal compiler to generate source code for the client stuff and server skeleton. Okay, then to distinguish the name, the client side library and the server side library. So here in COBA they use two different names. Stuff means client side library generated source code, and server side they use skeleton. Okay, this is the same thing. It's stuff library. Okay. It's similar to RPC, okay, but it's object-based. So client stuff we used in client side, okay, it's like a proxy of the server object. Okay. And server sector is in server side. It's like an agent of the client. Okay. So basic idea of syntax is something like that. You define a module. A module is a namespace or container, and then inside it here you have some objects, okay, and this object may inherit from other objects, okay, and you have a type, constant, exception, and attribute, whatever, okay, and with the parameters, the methods, functions, okay. So it's very similar to any object based language, okay, but they specific for use to define this, okay. So ideal compiler usually you take this definition and compile to generate two stub libraries. And here, ideal compiler usually you need to specify the target language is C++ or C or Java or whatever, okay. So they will generate this stub code based on what kind of high level language, okay. So the language dependent part is in these two, okay. After ideal compiler, so when you use an ideal compiler, you need to specify, okay, you need to what kind of high level language source code you try to generate, okay. You try to generate C or C++ or other, okay, and so on. And the interaction for client and server, the ob is a middleware, remember, okay. So they were doing the actual message passing and whatever, okay. So usually this is supported by COBA implementation, okay. So if a vendor or company they say he support a COBA environment, then they need to provide an implementation of this ob, okay, with an implementation of ideal compiler, okay, and so on, okay. So it's like a software bus, okay, and inside this bus they message it, the object client and server can communicate, okay. So if the client and the server are all in the same order, then this message deliver is just this way, right? You from the client go to ob and then go to corresponding server. If this server is not in the same order, then this order will send out through the network to find the target order, okay. So for example, server is in this particular order, then it's not in the same software bus, right? Then they send out the message through this IIoT protocol in the network. So other order can receive, and then they find out, okay, the server is in its order or not, okay. If it is in its, then deliver the request to this server, okay. And eventually the response will go through the reverse way and go back to corresponding clients, okay. And the whole set of ob architecture, we need to have a compiler, and also you have an interface repository. It's a database, a storage used to store all the defined ideal, okay. So the ideal compiler will generate stuff, right? But after you write you describe your object and this description, this ideal files, you need to have a way to preserve, usually we preserve, store in this interface repository, okay. And also without implementation, then this ideal make no sense, right? You need to, after you define, you need to implement the server, right? So after implement, then you need to tell the system, okay. So the implementation also preserve, maintained by this implementation repository, okay. And this order is used as a middleware. And also on top of this order, there will be an orb interface. Orb interface means client and server can communicate with this orb middleware, okay, by this through this interface, okay. Ideal compiler will generate stubs. These stubs will also put in implementation repository and also interface repository, okay. So when a client, so whenever you try to implement an application, And the first thing is that you go through this interface repository, try to find there's any predefined service, okay, you can use, okay, because here if the system they already have some object server was defined and their functionality is useful for your application, then you don't need to implement, right? You just use. Then you find out if you find some definition is useful, then you search for this implementing repository to find out is anyone already implement that, okay? Because sometimes you only get it defined but not yet implement yet, okay? So you need to search both repository to make sure, okay, this definition, this object server is already implemented, okay? If that's the case, then you can retrieve the client stuff. Okay, depends on the language. Okay, if they already has some precompiled client stuff, for example, the precompiled stuff maybe only for C++, but you like to implement your client by using Java or Python, then you can do what? You can use ideal compiler if the system support ideal compiler to generate your target language, for example Java or Python. Then although there's no client stuff for Java or Python, then you can use ideal compiler to generate for that. Use this ideal, okay, and then you get the client stuff. Now you can use this client stuff in your implementation. You just link the client stuff with your own implementation. Then inside your client application, you can call that particular server. Okay? If the server, if the implementation is there, okay. So that's the process of how to use this. Okay, but if you try to implement, then it's in different way. Okay. So for example, you try to implement some server, then you can look at this one and find out, okay, there's an implementation or not. You find out there's no implementation for this particular object. Then you can try to implement. Okay. And to implement, you need to link this skeleton. Okay. Then your implementation, after you implement and you test, no problem. Then you can put your implementation into this repository, okay, and become available by other clients. Okay. The standard way for client and server is like go through this client stuff, go through this stuff and skeleton. Okay. But later version, they because the implementation, okay, maybe always for some client, for some servers, okay, their implementation may be dynamically changed or whatever. Okay, it's not so mature or for any reason. Okay, then it's possible they can use this dynamic invocation mechanism. Instead of using static interface, you can use this dynamic interface, okay, to invoke some server without using its stuff. Okay. And this is a more general way to invoke any server. Okay. And here this DSI is the reverse. So if you implement a server object and you instead of use this skeleton fixed way to invoke, you may use this dynamic way to receive the request. Okay. So DSI is a counterpart of the DII. Okay. If the server support DSI, that means any client can use DII, this general mechanism to invoke, to send a request. So if this server they have linked this DSI, so that then it's possible a server can receive this dynamic invoked mechanism, okay, to invoke the service provided by this object. Okay. That's the current situation here. And conceptually, you can see that it's very similar to the RBC model, right? The only difference is it's just like it's an object based. Okay, it's not procedure based. Okay? So client, you implement this client code, connect to you use the client stuff to try to call this server. Okay? And this server may be in same org or in go through this IOP in other orgs. Okay. The coordinating based middleware. Okay. The first example is this Linda system. Okay. Linda is a coordination and communication mechanism or middleware among processes. They use store and retrieve data. Okay. The communication between two processes is using this shared storage. Okay. It's a type of distributed shared memory, but it's a special form of distributed shared memory because it's not normal memory, right? It's a storage. Okay. So this idea is first proposed by this David and Nick, okay, in Yale University. And actually, one of them is a PhD student, one of is advisor, okay, in 85. And later they transfer this to this company, okay. So and right now, last time I checked, it's still there, okay. So it will be able to retrieve this, okay. It's a TCP implementation, and of course you may have some other implementation. For example, Linux tuple or C Linda, okay, they are implemented by in this tool, okay. And you may able to find other implementation, okay, in GitHub also, okay. The idea is something like this: process communicate through this shared tuple space. Okay, so this shared storage, okay, it give a special name called tuple space. Okay. A tuple just a vector with dynamic number of or variable number of fields. Okay, so each tuple can have different number of fields. Okay, and this tuple space is a shared global repository that holds tuples. Okay, and process can put tuples there and retrieve tuple out of this tuple space, or read something out of this tuple space. Okay, so basic operation is something like this: you can put something in there, you can retrieve something, or delete something out, or only copy the content out. Okay, so but basically it has these three operations. Okay, and that's what is evaluate. You can evaluate something. Okay. So all tuple can be read and retrieved by any process. Okay. A tuple just a vector contain one or more fields, and the number of fields is variable. Okay, it's no restriction for that. It depends on your allocation, and each field is a value of some type. Okay, and this type it depends on what kind of language you are using. Okay, so usually it's language supported types. So usually this environment is implemented by adding a library, a set of library to an existing language. So for example, in C, in Java, or in whatever language. Okay. And basic in this model, originally they only require 4 operations: in, out, evaluate, and read. Okay. And this name is from the point of view of process, not from the point of view of tuple. Okay, so it means do something. Okay, take something out of the tuple space. So from the point of view of process is in. Out means put something out of the process, but for the tuple space is in. Okay, so out. So this in, out, evaluate, and read is from the point of view of process. Okay. Evaluate, you create a new process to perform some task, okay, in this tuple space for those related tuples. Okay. And do is just copy the content of match the tuple. Okay. Okay, so here conceptually something like you may have a process that may issue an evaluation or put output to create a new tuple in this tuple space. Okay, or in and read, that means read, you copy the content. In, you not just copy the content, but also delete those matched